Hey guys, welcome to my YouTube channel. So today we'll be talking about Spark architecture. To understand Spark architecture, we'll have to understand these two concepts. So let's get started. So basically what I mean by cluster based approach is cluster is nothing but a combination of machines. By combination of machines I just mean they are interconnected to each other. So let's say there are 10 machines. So and each machine has 20 cores as well as 100 GB RAM. So combined we'll be having 200 cores and 1 TB data at our disposal. So this is basically a concept of vertical scaling versus horizontal scaling. What we are using over here is horizontal scaling, as we are just interconnecting machines together rather than increasing the number of cores and RAM in a single machine. So another thing that Spark follows is master slave architecture. So in master slave architecture, one machine will be a master and the others will be a slave. So here I have noted it down. As I have said, there are 10 machines in our example. So this is M1, M2, M3. So on Mn is just like the end number of machines. So on M1, let's say for example, this master node can be on any machine. Let's say on M1 we have a master node. This is the master, the rest are the slaves. Then here a resource manager will be installed. If you don't know what manager is, I basically mentioned it over here. What resource manager is, what its task is, what driver is, what its responsibilities are. In case it's required, I'll make a separate video on this. So basically here a resource manager will be installed. Then after this, once the developer submits Spark submit code, say if you are working as your Databricks, you won't be running the Spark submit command. When you create cluster, all these things will be handled internally. But for our example, let's say you run the Spark submit command, as I mentioned over here, and you ask for all these details. So here, as you can see, I have asked for a driver worth 20 GB of RAM. So my resource manager will basically see which machines are free in the cluster. It will go here and see, okay, in this M2 machine it is free. And yeah, one more thing, as this is master, the rest will be its worker nodes. So these are W1, W2, Wn notation. They are basically worker nodes. So as I said here, a driver, this M2 machine will basically be our driver, this 20 GB RAM. So this M2 machine or this sub W1 will basically be our application master or driver, and inside this there will be, if you have written a code in your PySpark, then there will be a PySpark main method. But if you have written your code in Java or Scala, then it will be in Java main method or JVM main method. But since Spark works on JVM, so this PySpark main method will ultimately be converted in the JVM main method. So that's one thing that you have to look out for. And this JVM main method will basically be called the application driver. So now that we are done with driver, and yeah, as I said, there are 20 GB driver. So basically a 20 GB RAM, a 20 GB, basically a container will be created like this, and it won't exactly be 20 GB, as 10% of it will be memory overhead. So 20 plus to 22 GB container will be created inside this machine. Now once that is done, it will again go and check, okay, I also asked for these 5 executors, 25 GB memory, each having 5 is too much, it can be 3 to 4 cores, but let's take 5 for this example. So on the remaining machines, it will say, okay, for I need 5 executors. So let's take from W2 to W6 on each node, a container will again be created, and it's not necessary that containers will be created on separate node. If there is space, it will try to create a container in the same machine so as to avoid the shuffling, the data shuffling cost, basically the network input output, all that things. So here, as I said, 25 GB executor memory is there, so this will be having 25 GB memory. And again, it won't be just 25 GB, 10% overhead will be there, so it will be 27.5 GB, and each it will having 5 cores. So, and another thing, in these machines, these worker nodes, basically only JVM main method will be running. The Python, it doesn't understand Python. The Python packages won't be installed. So if you have written UDF, user defined functions, in your code, Then Python libraries will also need to be installed. So this will consume space, as well as Spark doesn't really understand Python's methods, so it won't be able to optimize your code for you. So that's another thing that you will have to take into consideration. So the basic flow now, what I say is, you have asked for all these details, all these things have been initialized. Once you submit your code, the resource manager will, as I said, either see whatever free machines are there, either create all these containers. Then the driver will basically, as I said, as I mentioned over here, the driver is responsible for breaking your data into separate stages and tasks. So it will send all your data to these separate machines. These worker nodes will basically work on your data, whatever transformations actions you have mentioned, it will do all that. And depending, say you have called the collect or show metadata, return data to your master node, or if you have written write, if you are using the write method to write back somewhere, it will write data back to say Snowflake, SQL Server, or ADLS folders, whatever your output you have mentioned. So this is basically what Spark architecture is. If you guys have any doubt, please let me know in the comment section. Thank you, goodbye, see you in the next video.